Hi, I'm Stefan Bückelmann, the organizer and host of the emBO++ conference, the next level conference for embedded software developers. The talk you're about to see is about C++ STL multithreading in RTOS projects. It was given by Piotr Grygorczuk at the emBO++ conference 2021, and thanks to Leica Geosystems, you can watch this video online for free.
Okay, let's start. Um, so, um, my name is Piotr, and today I would like to introduce you my library. I enable the STL C++ multithreading in FreeRTOS, but FreeRTOS is just an example. I would like to show you the way how to uh, rather to show a pattern how to do this for other systems as well. Uh, so um, yeah, so let's. I hope it will be useful. um, so my motivation for creating this library was basically I wanted to use the standard library mutex and threads in bare metal systems, and I found it it's problem that something that the rules for that is for the threads and mutex before some sort of low-level treaties to enable the performance. And most of the operating systems are using the C, which is kernel itself, and ARM, but C++, really because there's so many systems that some of them could be, but most of them they have a specific API, and none of them are actually integrated with the STL. So this is an example of how FreeRTOS is using a specific API. So let's say some function, and that's the API from the FreeRTOS to pass the function that task will be executed. Give a name. We have to define stack, priority, pass some argument to that function, which will be coming this, and in return we'll receive and handle, and then we can do something in parallel. And when the function completes, we have resources. And yes, I can. Yeah. Is it better this way? Okay, sorry for that. Good to know. Let me know if because the microphone is moving. So if something is wrong, just let me know again. Okay. Yeah. So it's just an example for FreeRTOS, but I believe that most of systems will have a very similar API. Um, so what are the solutions out there? So most of it I saw people create their own wrappers for std thread. This is not that bad idea, considering that it's portable. So depending on what compiler you use, your class may work. Um, however, from my perspective, I had the impression that this is the re-implementing what's already out there. So unfortunately, each STL implementation is unique for the vendor. So the C++ standard doesn't tell how the implementation should look like. So um, my example is just purely for GCC, but if you're using different compiler, that's probably have to look and see how the STL is there implemented. And so my question is like, why not to use that? If I'm using GCC, why should I create wrappers and debug them and test it? GCC has it already, so why not to use it? What stops me from it? So that was kind of a challenge, curiosity how to do it, and something useful for like projects I was working on, or maybe for somebody else. So why FreeRTOS? It's just purely personal preference. I'm not working for for FreeRTOS, or I'm not working for Amazon. So Amazon is the current owner of FreeRTOS, and FreeRTOS is the popularity is growing since Amazon owns it, and it's promoting to use with Amazon Web Services. You can see more and more people using it. It's very basic. It's less than 10 files, considering it's just a scheduler and some synchronization objects. But it has a good number of extension libraries. For example, MQTT is used for communication with web services. There is, yeah, there's like radio communication, fast, TCP, and a few more. And again, FreeRTOS is just an example. This is something I did, but I will try to focus and show how this can be ported to possibly other systems. Okay, so how to do it? Before we go to details, I would like to show the kind of block diagram, top level picture, and it's simple. So my library is hidden here, and user application will be not interacting with that library directly. It, it just program will use this just a standard GCC STL implementation, and that implementation will interact through my library to the OS kernel. Obviously, user has access to FreeRTOS API, but that's not necessary. I mean, certain functions which are not implemented in STL, yes, but other than that, that's the area. There's actually one function which a user will need to use. That's for setting up time, but I will I tell about it later. So like people are familiar at this conference, I guess, C++ with the thread support library. So it's quite a lot there, but the good news is that we don't have to implement everything. The GCC is kind of self-dependent, and this is the scope of work. That's one of those components are on the slide implemented. The rest of features pretty much work. I'm not sure about the C++20. I haven't tried yet. I know, for example, GCC 10 doesn't have semaphores and latches implementation. So I tested with the older standard. That C++20 is something for me to work on. Okay, so how GCC hook. So basically, how does the library interface with GCC? So I use the ARM compiler, and if you look at the STL implementation, all of them they include this file. This is gthread-h, and there's no single file. There's many of them, and basically it depends. So when you compile your program, you have to pass the parameter to the compiler about your architecture. And depending on this architecture, compiler will pick different implementation of that file. So for ARM none, this file is always the same as far as I remember, but it could be different. And all of them, they include this guy. This is the gthread default. There's also gthread POSIX, and I don't remember the moment, possibly some other files, but that's the one being used. And I call it GCC hook, and I will reference this file quite a few times in my presentation. So this is the first merging point. And second one is this definition. So this is for the GCC to tell that the multi-threading is present in the system. So in my case, I just define this in the CMake script. I'm not sure if there's a different way of doing it, but that's anyway, it has to be visible in your project. Yeah, so what kind of stuff is in this GCC hook? So the types here, that's the types that the STL is using. And then I'm just doing a mapping to my own types. So for example, semaphore handle is something from FreeRTOS, and the reason for that is because the mutex implementation is just pretty much matching the mutex implementation here, so I don't need any extra type. But for example, condition variable and threads, they require some extra implementation. So this is introduction of types, and the next part in that file are those functions, and all of them, they have to be implemented if we want to um, have the full implementation. So there are keys. At the beginning, when I started implementation, I didn't know what they are needed for, but then they actually used with futures. So I'll tell about these functions later. Then there's 12 functions for mutex, just the standard mutex and recursive. And then thread functions and one condition variable. Yeah, so this is pretty much all what's inside of that file. And just next thing is how to implement it. So I start with mutex because it's the simplest part. And again, that's the type. We have functions, and those functions are called from inside of the STL, and they just do the translation to the, in this case, in FreeRTOS, but basically if you want to implement different system, that's the merging point. You have to pass that, you have to make the calls to your OS. And yeah, so just point that the mutex lock is using infinite time. And then there is also another function, which is timed lock, and requires this get time of day function, and then the conversion to time and pass the timer as it ticks. So this function is used in a few places. So I will tell about it a little bit later, but basically it's just returns the system time. So if you look at that, I go back one slide. So this is 5 functions, and this is 6th one. This is for standard mutex, and then for the another 6 is for the recursive mutex, making it total 12. And once you have it, that's it. You can use this to the mutex in your application already. So next is condition variable. So on the left is that's exactly how it is in GCC. This is the GCC implementation. And you can see here that they have this native type. That's the condition variable primitive. And it's just, this is the mapping to the type in my GCC hook. And then I had to introduce my own type. So I tried to implement the condition variable myself, and I found it not so easy as I thought. And then I found this interesting article. It's not so long, it's just a couple of pages, but it's a nice study of Microsoft engineers, how they try to implement the condition variable. And it was actually interesting to find out that I was going the same path and going to the same issues. So if you're doing yours, so the last sentence, you should either do the queuing yourself or lobby your kernel implementer to provide a suitable primitive. So basically, if you have operating system which doesn't have a condition variable primitive, do the queuing. And that's the case for the FreeRTOS. And so that's the approach I took. So that's the my type, and it's matching here. So it's basically a queue of threads plus some semaphore to synchronize the access to to that list, and the remaining functions is just functions for integration, like moving, adding threads to that list, removing, and some extra stuff to interact with those. So the functions that have to be implemented. So there are some functions already implemented in GCC, but there's yeah. So the constructor and the structure is just default. I didn't have to provide anything there. So it's just a default. The wait with predicate depends on the wait without predicate, and then there is also another wait I didn't show on that slide. Is a timed wait, which is also implemented, but it's accessing this GCC hook file, as I call it. So the implementation is there, but it's pretty much the same as wait, except that there is some extra time. So here it is. The wait function just takes the lock, the mutex. The mutex has to be locked already. There's some synchronization access to the queue to push the current thread handle to that queue. And then we unlock the mutex, and we are just waiting for event with the infinite timeout. So the timed wait will differ in the way that one of the arguments will be time, and we have to convert it to some, in this case, FreeRTOS requires ticks instead of milliseconds or other time format, just ticks. Yeah, so just waiting and notify one. Again, we are locking the access to queue. If there is any thread waiting, we just pop the thread from the queue, and we send the notification to that thread. Simple as that. No more. It's not that complex. I mean, it was complex when I tried to implement at the beginning, but once I found out what is really needed, it turned out it's trivial. And the notify all, it's the same function, except if there will be while loop going through the all the items in the queue. So that's it about the condition variable. Just let me check if there is any questions. There is no stream and no sound for me. Can somebody confirm that actually it works for everybody else? Yeah, okay. So, oof, I thought I would be talking to myself for that time. Okay, I don't see the questions, so I will continue. Okay, so next thing is threads, and before I go to implementation, is a little bit introduction. So a thread was a little bit mind-bending for me, and until I had to come to realization. Normally, when we implement in C, we have a handle. It's just a single pointer. But in STL, we have the entire object that is living in its own thread, while the spawn thread is living on its own life. And then those two, they have to somehow communicate. So the way how I solve that problem is just basically there is a state, and the state has to be shared between the two. So then I came to a problem when actually the threads, the handles uh, shall be allocated and then when they should be released. So for example, like in detach case, the thread can spawn the thread and immediately after that could be detached and the structure could be called. And so the instance of the thread will disappear. I would just use the laser maybe. The instance will disappear while the task function is still alive. So the structure must not release the handle of the thread. Um, and same other way around when the instance of the thread leaves and the task function returns earlier. Um, when we call the join, um, we have to know that we must not block. So there is some sort of communication going on between those threads. Um, so it's not that difficult, but it's just awareness of that is important. Um, Again, this is the on the left. There is implementation of the thread inside of the GCC standard template library, and that's the thread handle. It's inside the class, so the instance is actually here. Um, and again, this type is translated to this guy, which again, I had to introduce this in my GCC hook, and I provided my own implementation. So the implementation looks like this. So I have the FreeRTOS handle. I have some events handled for sending messages. So FreeRTOS has an interesting feature where it has the event groups, which I found works quite well for me. Um, I believe it can be implemented with some other mutexes or semaphores, um, but I was struggling a little bit, and then I found that event group works easier for me, so that's the path I took. There's this argument pointer. That's something which is to hold the state, but again, it's part of the state. So I will talk about this in a few seconds about it. But here is the structure of the std thread state. So I keep the pointer to it. Plus, I have some local variable, class variable owner. So this handle here, it's passed a couple of times, moved and copied, and so I track who is the owner of the resources, so I can be sure that when I destroy the instance of this gthread FreeRTOS object, I know that who is responsible for releasing it. Interesting part is here. This is the state. So what happens is when the thread is created, um, I have to call that guy here, and you can see that the signature, the arguments are different. So so the state, and you can see there is no really any variable that holds the state here, and the state is the unique pointer. So what happens that the unique pointer is passed here as an argument. So yeah, I found it a little bit tricky to initially to find out the pattern, how it should be implemented. So here is a little bit pseudo code to explain what's going to happen, and then I will get to more detailed descriptions of functions later. So basically, when the thread when the thread constructor is called, the user function is passed as an argument, and that function is wrapped into a state pointer, which is the unique pointer. Then next, the gthread, this GCC hook function is passed, passing the not the ID but the handle inside, plus the state as well, then something is going on inside, and the create thread from my library is called eventually, which will create the FreeRTOS thread. But what's interesting, the FreeRTOS will be created not with the user function, but some internal local free function. And that free function has some responsibilities. So basically, it has to make the copy of the state. It has to notify, set the event that actually this function is running, and then create the finally run the user um, function. When the user function returns, we have to notify the joined and then clean up after all the resources. So create thread. Um, um, Again, that argument will be passed as a std thread state, which is the resources held by the unique pointer, and just simple assignment. Plus, there is a um, extra handles created. That's stuff from the FreeRTOS. Here's the function which is created. It's that path here is a task. This is important note. So STL doesn't provide a interface to specify stack size or priority. So here is the it's fixed one for all. And if you require to modify this, you will be doing this for all threads in your application. And I'm passing this, my class instance pointer, which will come as an argument to that function there. So that's how the thread is created. And here is the implementation of the merging point with this toThread class. So I will start with the bottom function. So creates start thread. It's passed that the unique pointer. This function is not used. This is the case when create thread could be passed as a function pointer, but it's called here directly. So this is the GCC hook, passing the address of my uh, handle to my implementation of the thread, plus the exit the function native one, which is above. And here's the important thing: because the state is a unique pointer, it means that it will, if we don't handle this properly, it will be just the resources will be released here, and that must not happen. Um, so we pass the row pointer, but at the same time we have to be sure that actually our native thread function executes. Otherwise, we'll have resource leak. Oh yeah, there's one thing I forgot to tell, so I go back 2 slides. So actually this task function is here, that's the state, which is the virtual function. So um, so now if I pass forward back to this native thread, you can see here that the my local object is passed as an argument, and I make its copy. And then because we have to do this because it could be that the this thread could detach and just basically destroy. Just yeah, the destructor can be called. So I have to have my own internal copy. Then I'm making a copy of this argument which was passed as a unique pointer here. And then I'm just basically I'm saying that I'm ready. The thread is already running. So remember that this is the function which was passed to the FreeRTOS as a thread. So this is actually thread running. So all these copies has been made, and we notify that started, and this is the place where users function is actually called. So once the thread is when the user's thread function exits, um, we go outside the scope, we release the state, we notify that we finished. There's some extra code executed here. I will come back to it later. Yes, and this is pretty much all. And then implementation of join and detach is simple. So basically, if the thread is actually running, um, is created. So basically, we can create a. It's invalid to call join on thread instance which hasn't started, was not given any task to run. So it was just default constructor. That's not valid. So here is a test that actually um, the thread has been created. And this is again GCC hook calling join, and join here on the right side is just basically waiting for the event being set. So if I go back slides a little bit, here is notify joined, and that's the signal which will set the flag here, and join will be released. Much the same. Here is, as you can see, the function is the same. It's just a change in different GCC hook. And implementation here, detach must not um, must wait until the thread is actually starts. So as I showed you before, the state has to be copied before we, because if we do the detach and the destructor is called just after the detach, that could be disastrous. So we are waiting for actually the thread to start and to make all the copies initialization, and then we are free to go. Um, and then actually, if the thread function was really short, there's a chance that by the time we get here, the thread actually could be deleted. So we just make sure that this didn't happen here. Um, so this is pretty much all about the thread. So if there are any questions, I'm gonna listen, because the threads could be a little bit confusing. So um, please ask if you have any. Um, okay, if I start presenting, okay. Is this tied to GCC? So the question, John McFarlane, is this tied to GCC 8? No, so GCC 8 I was testing, but I used before GCC 7. Recently I started using GCC 10 as well, but the difference is that um, the standard, so C++14 or C++17, that's what I tested with. If I use 20, there's some compilation issues. That's something for me to work on, um, but that's not done. Next question: what about configurable stack size per thread? Yes, so this is exactly what I said. So STL doesn't have it. Um, and if I try to be compliant with the STL, so I can't to add configurable stack size per thread. That would require probably modification of the GCC implementation, and this is something I will. That's not more. That wasn't my goal. I tried to keep it just compliant with the C++ standard, and but obviously if that's the limitation, that probably can someone individually go and modify GCC. Does the implementation throw exceptions? No, so in my code I don't throw exceptions. So if I go back to here, you can see that this is a throw system error. Um, so this is the standard function of the implemented by GCC. So I actually don't know what's going on there. Is it just terminate, or it will throw literally exceptions? So I'm not sure about that. But I've seen this kind of approach in other places in library, so I just mimic it. Um, so I'm not sure which is it going to throw or terminate. Okay. Um, okay. Next question: is there a configuration file for the stack size and priority? Um, so in my implementation, I just literally put it like this. This is in Word, so this is basically 1 kilobyte. And priority is it's idle priority. It's defined by FreeRTOS. But yes, look, it's all of it is available as a source code, so free to modify that. But yeah, I can probably add this as a configuration parameter in some header file. But at the moment, that's literally how it is implemented.
Wir sind hier in einem kleineren Grossraumbüro.
Bei den Leitern habe ich die Freiheit, dass ich, wenn ich anfange und wenn ich höre mit dem Arbeiten, eigentlich selber einteilen kann.
Overall, how I will do it, it's just up to me and they give me a lot of freedom.
Für mich ist die Faszination, mit anderen Leuten einen kreativen Moment zu generieren.
Great colleagues, great environment basically.
It's really nice here and I don't have any issues living here.
Am meisten schätze ich in den Leica Geosystems, dass wir ein sehr junges Team sind, sowie dass ich auch meine Arbeitszeit in einem gewissen Raum selber bestimmen kann.
And I could merge my life hobby with my office job.
Das Besondere an der Leica Geosystem ist sicher die Kultur und die Dynamik, die es gibt in dem Team. Es ist jeden Tag ein bisschen anders.
We have good organization which will help you to get used to the company in the first couple of months especially.
Das ist sehr interessant und ja, macht mir Spaß.
Next question: how difficult would be a port to a new C++ version such as C++20? So I tried to do it, and if you go to my repository, there will be a link at the end of presentation. I have some initial work on C++20, and it's a separate branch. So if you go to the branches, there will be my C++20 work. I had some issues which required a little bit modifying the code of my library. For example, STD_thread is using this spaceship comparison function, which obviously 17 and Prior20 doesn't have it. And so that was one of the things that failed. Another one, there was some wrong definition. There was some extra include file which is not needed, and there was some circular dependency. So yes, so there is basically some work. I don't think it's a big issue to port it to C++20, but that's something I have to. I believe it will work. So I know that the GCC 10, which is a non-EABI, the recent build, it doesn't have, for example, semaphores, so that's not going to work. Same like latch and barriers. JThread, I think JThread is based on just a STD_thread implementation, so it should work out of the box. But again, that's something for me to work on. It's not ready. So next question. Is it okay to combine FreeRTOS row task with STD_threads for getting other priority? Yes, so that should be possible. As you could see in my library, I'm not really modifying any existing code, or I'm not modifying FreeRTOS. I'm not modifying GCC implementation. I'm just adding my code to do that. So I absolutely see no reason for why you couldn't use the native API to create your own tasks. Also, I would like to highlight that although I was using ARM, I don't have really dependency on ARM, and I think that I had access to some PowerPC evaluation kit boards and exact same implementation compiled for PowerPC. So as long as you're using GCC and the FreeRTOS port exists for the platform, I see no reason why it wouldn't work. So I'm using GCC for ARM just because that's something that it's available to me at home. But I tested PowerPC worked. I believe that other platforms should work as well. In C++20, did you look at JThread yet? Yes, I looked at this, and this is exactly what I answered to other question. It's I believe it's matching it's using internally std thread, so it should work. I haven't tried it running yet, but I believe that there shouldn't be issues. Okay, so I don't see more questions, so good to go. So this is thread. Oh yeah, okay. So there are two more functions in std this thread. It's a sleep for and sleep until. So sleep for is implemented, but it's calling internally __ sleep for, which takes the seconds and nanoseconds from chrono. And the implementation, again, it's trivial. I guess every operating system has some sort of delay function, which in case of FreeRTOS, that's the vtask delay. And just the whole implementation is converting the chrono time to ticks from milliseconds to ticks, and that's all. It's done. Sleep until, it's fully implemented, but it has dependency on get time of day. And also, as far as I'm aware, ISO standard does not provide a function to set the time. There is a function to get time, but there's not none to set time. So this is the only function in my library that could be referenced by the user application, and it's basically setting time. And the way how I implement it is that I just basically store some a clock or a calendar, or let's call this, like I call this wall clock, in global variable inside of my library. This is the delta between the time being set by user and number of system ticks that the system is running. So this is just a conversion to seconds and microsecond. And then once it's done, get time of day is it's a reversed operation. Is just basically get the time offset, which was calculated the set time plus the current ticks. So it's done separately because it's a critical section, just to make sure that they're not getting interrupted. And then the operation here is just basically adding, so converting ticks to milliseconds and just basically adding. So in the previous function, it was subtracting, here's adding. So it might be a little bit confusing here, but that's a simple operation like this, just basically add, and then the time will be returned through this argument. And get time of day, it's trivial, but it's used by any timed feature. So it's used by time mutex, and it also used by condition variable timed wait. Futures. So at the beginning, I was looking at my own implementation, and I found it difficult, okay? And then I realized that I will be mimicking this pattern of people creating their own wrappers. And then I realized, like, wait a minute, it's there, it's already implemented. So how to do it and why it's not working? And then I found out there's this ARM non-EABI is implemented for single. It's basically compiler is non-EABI is dedicated for single threaded. So basically, there's some compile flags set to say that anything related to multi-threading can be removed from the compilation, and this is the case for the futures. And then I realized that if I include those three files, mutex cc, future cc, condition variable cc directly in my code, it works. So all the implementation was there, and it was just basically missing from the build. But then um, I I had a dilemma about the license, so I didn't want to release my library with GPL v3, which is the case for the GCC compiler. But there is the GCC has this extra thing which is called GCC runtime exception, and it's basically, in short, it's a recognition of the fact that when you build your own application, which could be proprietary, and you want to make money selling it, it's necessary to include certain GCC portions of code, for example, as header files, which is the source, and it will be compiled into your application, or even you link with the static std_libc, and it will become part of that. This part of the GCC will become part of your application. So this runtime exception is just basically a permission that it's recognized that that's the case, and this allowed to do. And it just basically say you don't have to release your code as GPL, which was very good news for me. Yeah, so my library is released as MIT, and those three files are they are still GPL v3, obviously, because they are still part of the GCC, but they are part of the build system. Oh yeah, so the mutex was needed to make the call once working, futures obviously to make futures working, and then condition variable was a little bit confusing because I have my own implementation, but then I still need that file because there is at ThreadExit. So I had to remove some code, which is basically linker was screaming that there was multiple definitions. So I commented out some code from that file just to make this at ThreadExit working. So again, we are coming back to this gthread default, my GCC hook file, where they have a gthread once. So this is just a flag. This is the function that has to be called at once, and I'm just using a static mutex where I synchronize the access. I swap the flag. So basically, what happens is that when the function is called for the first time, it will get called here, but when it's called second time, it won't get here. So what's interesting here is that imagine you can call, you can pass the function to call once, and that function will be called here. And inside of that function, you could call once again on a different function, but with the same flag or different flag. So it was kind of recursive, but then I realized that, yeah, so I made the recursive semaphores, but I don't think they are needed at this stage because I moved the call outside of the synchronization block. That's the call once, and then there's notify all at ThreadExit and set value at ThreadExit. So those functions are already implemented. Full implementation is out there, but those functions have dependency on the key. So there's 4 functions in a GCC hook file: create, delete, and then accessors, which is get specific and set specific. For a moment on the create, there is a function pointer destructor passed. And then, so this is important. I will tell that about it in a minute. The structure is just delete the resources and then set specific. So basically, this key works the way that each thread could set um, um, some specific value which is associated with the thread. So I'm not sure. I tried to find how this key is implemented in Linux or some other implementations and POSIX. I found it a little bit difficult to fish the implementation, but I kind of reversed the engineering of. I looked at what STL actually requires and I implemented. So I'm not sure if this is the proper implementation, how the key should be implemented, if we want to use it in any particular case that POSIX designed it. But I believe that this is the implementation that it's matching how STL is using. So the way how I implement it is that it's basically I have my own type, and I have an ordered a map of the threads and the specific value. So each thread has a one single value associated. And it's interesting, STL has a feature where if there's more needed, it's just basically, it's linked list past this here as an argument. So basically a single thread can have a linked list of arguments. But again, that's the implementation specific of the STL. What I was interested, I was just basically like, how am I going to hold it and pass between the functions? So that's the map. There is this mutex for synchronization of access to this. And the structure pointer function is the one which is passed in constructor. It's here, initialized. And then there is this call destructor. So remember that we are talking about at thread exit. So when thread exits, there's expected that something will happen. So this is the function, and going back in time. So when I was talking about the thread, I introduced you to this native thread function. So it's a little bit shorter here, so you can, if you remember, that's the user function being called from inside of this. And when the user function exits, that's exactly what you expected. At thread exit, I have to call this destructors, or I'm just passing this. And the implementation of the function is just basically, I lock the, here's the queue. So I lock the queue. I search if there is any task actually stored the data. And if it did, I call, I get the value, and I call the structure from that. So there is some implementation in STL going on behind, but again, it was required for me to understand how it works. But so if you are planning your own implementation, you know, it requires to look there and make sure that you understand how it's working, or you just mimic my structure of code. Yeah, so the last thing on my list, which I would like to talk today, is the ThreadLocal, and it's a bad news. It's not working, and the reason for that, I suspect, I don't have confidence, but I suspect there's this function in gthread default, and it's simple as this. This just return 1. So the original function returns 0 because it's a single threaded. No, ARM non-EABI is single threaded, and I'm just adding the multi-threading support to the compiler, which is not compiled for multi-threaded. And I believe that this 0, which is in original code, is basically inlined whenever the flag is tested. and basically if I create a ThreadLocal in my library, the variable is not really ThreadLocal. It's just it's global for everybody. So this is pretty much all. So files in the library, it's very simple. It's short. So I have my GCC hook, condition variables. I have my FreeRTOS time functions thread. There's a key implementation. There's three files from GCC, and at the end, this flag has to be set somewhere in the compile time to be visible by all the files, and that is it. So thank you very much, and now questions. Is there benchmark of the library RAM speed overhead? No, I didn't do it, but there is definitely, if you compare native, if you compare the native FreeRTOS as a C implementation and then STL, I'm not sure. You can see that there is some virtual state. The function is passed as a unique pointer with the polymorphic type is created. That's one thing. But again, if you want to mimic the same behavior in C, that's probably you would need to implement something similar. I noticed one thing. So basically, you don't need features. You don't need features if you don't use them. Okay, and you can use the stud thread on its own. And then when I was working on features components, I realized that definitely they require bigger stack. I didn't figure out how much bigger, but I think I don't remember the moment, but if basic C function could work maybe on 200 bytes stack, that's definitely not enough for futures. Okay, is there more questions? Have you had GCC developers confirm the GPL license exception? No, I didn't have it, but I went to I was concerned about license, and I asked the on one of those I don't remember exactly, this like Stack Overflow. There is a page related to software licenses, and that's exactly where I kind of posted the question with my concern, and I received the answer that that's the how it is designed to do this. So I didn't make an effort to talk to GCC developers directly, no. I don't see more questions, so I guess, look, I'll be around for entire emBO. If you have questions and you want to talk, I'm happy to have a chat, and I probably should step off the speaking place to get the next speaker to get ready. Thank you very much, and hope to have a chat around in this virtual world. Thank you. Bye-bye.
If you found this video informative, make sure to subscribe our channel. Click the thumbs up if you liked it, or leave us a comment on what we could improve. If you are looking for a job in the embedded industry, or you've got one to offer, drop us a mail to jobs@embo.io. That's jobs@embo.io. And we'll make sure that you match up. My name is Stefan Bückelmann, and as long as you keep watching, we'll keep covering the internals of the embedded industry.